Now see, children, today we will start a new chapter of Standard 9 CBSE. That is chapter number 9. Name of the chapter is Areas of Parallelogram and Triangles. Standard 9 CBSE Maths. Now see, we have already learned in previous class about the areas of simple closed figure like rectangle, square, triangle and parallelogram. Okay? In previous lesson also and in previous class also, we learn about the area of simple closed figure like rectangle, square, triangles, parallelogram, even circle also. And we have a ready-made formula for those. They come under mensuration. Now what do you mean by area? See, you have learned the formula, and by using formula you calculated area of many closed figure like rectangle, square. But do you know what is the area? What do you mean by area? The measure or the magnitude of a planar region. And planar region is a part of the plane enclosed by a simple closed figure. See, what do you mean by first planar region? Okay, first we define planar region. What is planar region? The part of a part enclosed part of plane. Okay? Planar region is the part of a plane. Is the part of a plane. Of plane enclosed by planar region is a part of plane enclosed by a simple closed figure. It can be rectangle, it can be triangle, it can be circle, it can be square and anything. It can be quadrilateral, okay? And what is the area now? The magnitude of plane and the magnitude of and the measure, or another words में हम बोल सकते हैं measure और magnitude of a planar region is called area. A part of plane enclosed by a closed figure is called planar region, and the measure or magnitude of planar region of that closed figure we call it as an area, and it is measured in square unit. In square unit, okay? If your measurements are given in terms of centimeter, so it is centimeter square. If your measurements are given in terms of meter, it is square meter. Now, see, in your previous class, you have learned, not only previous class, in previous topics also, you have learned about congruent figure. याद है? What do you mean by congruent figures? When you can say that two figures are congruent? You know, two figures are called congruent. Two figures or more than two figures are called congruent if they have same shape and same size. Okay, if they have, we have learned this, they have same shape and same size. Right? And also we can say that two figures A and B are congruent, then they must have equal area. Or we can say if two figures are congruent figures are always equal in area, okay? Then two figures are congruent, then their areas are also two figures A and B are congruent, then area of A is equal to area of B. If areas are equal, then they are not congruent, but if figures are congruent, then their areas are equal. That we have learned in our previous chapter. And if triangle, so we have learned more than 4 rules. Two triangles are congruent, then rules for congruency are SSS, SAS, AAS, ASA and RHS. Okay? But this area are equal. Congruent figure ka areas are equal. But the converse is not true. Converse is not true. Suppose area of A is equal to area of B. It does not imply A and B are congruent, okay? जरूरी नहीं है कि areas are equal then figures are congruent. For example, I give you one example. Suppose you are given a rectangle, okay? This is a rectangle A, B. It always form 90 degree, okay? तो rectangle के लिए all angles should be 90 degree. Suppose ABCD is a rectangle, all angles are of 90 degree. And suppose this AB is 9 centimeter and BC is 4 centimeter. Then what is area of ABCD? L into B. So it is 9 into 4, so 36 centimeter square. Suppose I take another example of a square. Okay? If I draw a square ABCD of measurement 6 centimeter by 6 centimeter. So area of square ABCD is coming 6 into 6, that is also 36. So areas of square and rectangle are equal, okay? See, area of rectangle is equal to area of square, right? But it does not imply square and rectangle are not congruent, okay? That implies rectangle is not congruent to square, okay? Here both figures are different. They do not have same shape. Their areas are equal, so they are not congruent, okay? Also, if a planar region formed by T is made up of two non-overlapping planar regions formed by figure P and Q, then area of T is equal to area of P plus area of Q. This first is if areas are equal, then figures are not congruent. And second, if a planar region of figure T is made up of two non-overlapping planar region P and Q. Then you see the figure. Area of T is area of P plus area of Q. Figure will be like this. Suppose कोई भी दो है, suppose एक ऐसा है, ऐसा figure है. This is my figure T. It is a P and Q. Figure T is made up of planar figure P and Q. Then area of figure T is area of figure P plus area of planar region Q. Clear? So the two things you have to remember for A1. Now we shall study some relationship between the areas of geometrical figure lying on the same base and between same parallel. The important aspect of this topic is we shall study some relationship between the areas of geometrical figure lying on the same base and between same parallel. Okay? So now we shall study some relationship between the areas of geometrical figures lying on the same base and between the same parallels. Look at the following figures. Look at the following figures. देखो मैं एक फिगर बनाती हूँ, आप देखना. Now see, I give name A, B, D, C and E, F. Look here, what do you observe here? Here you see trapezium ABCD, okay? Trapezium ABCD, ABDC, दिख रहा है आपको? And parallelogram CDFE और EFDC, कुछ भी. This trapezium ABCD and parallelogram CDFE are on the same base CD, but not between same parallel. They are lying on the same base, but they are not lying between same parallels, okay? Because CD is parallel to AB and CD is parallel to EF also, but AB and EF are not on the same line. So here trapezium ABDC and CDFE. This parallelogram, they are on the same base CD, but they are not between the same parallel. Okay. Now let us take the second figure. सेकंड फिगर में आप देखना, ये बनाया मैंने पैरेललोग्राम. ओके. एक दूसरा पैरेललोग्राम मैंने बनाया, इसको एक्सटेंड किया. ओके. एक लिया मैंने ए बी सी एंड डी, एंड दूसरा मैंने लिया ई एफ सी डी. नाउ सी, इन फिगर 2 you see parallelogram ABCD and parallelogram EFCD. You see they are on the same base DC and between same parallels DC and AF. देखो, clear? So if the two parallelograms are on the same base and between same parallel, then they are always equal in area. That we are going to learn as an important theorem in next lecture. Okay? Or later on. Now see the figure. See this figure. Now I construct B, C, A, and this is D, E and F. You see, you can see two triangles, right? Here in figure you see triangle ABC and triangle DF are not on the same base, not on the same base, but they are between same parallel. They are lying between same parallel. What are those two parallels? BC and AD. Okay. BC and AD. They are between same parallels BC and AD. Okay. Two parallel lines के बीच में both triangles are lying. So when two triangles are on same base and between same parallel, then they are also equal in area. But suppose you are given one triangle and one parallelogram. They are on the same base and between same parallel. Then what to do? Suppose I draw the figure. Now look here. This is A, B, C, D. This is a parallelogram. And P, D, C is a triangle. Okay. So here what do you observe? Parallelogram ABCD and triangle PCD are on the same base DC and between same parallel DC and AP. So when a parallelogram and triangle are on same base and between same parallel, then area of triangle PDC is 1/2 time area of parallelogram ABCD. Why? See, you know, area, if I draw from A see, if I draw perpendicular on BC, okay, A, B, C, D is a parallelogram and P, C, D is a triangle. Now if I draw perpendicular from P, M, perpendicular to CD, then you know what is area of triangle PDC. We know it is 1/2 CD into PM. Clear? And what is area of parallelogram ABCD? That also you have learned in your previous standard. It is CD into PM, base into height. Now see what is the relation between 1 and 2. Relation is as given in this capital 1. Clear? Capital 1 relation is depending on number 1 and 2. Triangle का area 1/2 base into height and parallelogram का area base into height. So when the triangle and parallelogram are on same base and between same parallel, then area of triangle is 1/2 time area of a parallelogram. Okay? Clear? So this way we have learned about the relationship between the areas of geometrical figure lying on the same base and between the same parallel. Now all this relation we are going to learn in form of theorems. Okay? Now see theorem 9.1. Theorem 9.1 gives you relation between area of two parallelograms on same base and between two same parallels. Then they are always equal in areas. Theorem 9.1, the statement is parallelogram on the same base and between same parallels the same parallels are equal in area. They are always equal in area. Right? Now this theorem we are proving. For theorem, as you know, first we should write down what is given. Okay? So first you write down your given data. Then you write down what is to prove. And here you have to draw figure. Clear? What is your given data? Tell me. From this statement I can write it in mathematical form. नाम दे देंगे two parallelograms A, B, C, D and E, F, C, D are on the same base. कॉमन क्या है उसमें? DC and between same parallels. कौन से दो पैरेलल्स आएंगे? फिगर में देखो. पहले हम इधर फिगर बनाते हैं. ओके? एक हमने पैरेललोग्राम बनाया. ओके? ABCD. दूसरा पैरेललोग्राम बनाया CDF. देखो A, B, C, D and this is E and this is F. Have you seen two parallelogram? ABCD and EFCD. These are the two parallelogram are on same base CD and between same parallel CD and AF. Same parallels DC and AF. Clear? This is my given data. What is my to prove data? To prove data is area of parallelogram ABCD is equal to area of parallelogram EFCD. That what we want to prove. Clear? अब देखो प्रूफ में हम कॉन्ग्रुएंसी ऑफ ट्राइंगल यूज करने वाले हैं. ट्राइंगल ADE एंड BCF. तो उसमें पहले हम एंगल बता देते हैं. दिस एंगल मस्ट बी इक्वल टू दिस एंगल, करस्पॉन्डिंग एंगल. फिर दिस एंगल is going to be equal to this angle. This is also corresponding angle. And दूसरा क्या लेंगे हम? AD is equal to BC. So by ASA, two triangles are going to be congruent. When two triangles are congruent, their areas are equal. And in that area, I am going to add areas of this part. EDCB. I am adding in first triangle also. Then it is going to become ABCD. And I am adding this triangle. Then it is going to become EFCD. Clear? समझ में आ रहा है? अब हम कर रहे हैं प्रूफ. प्रूफ में हम क्या करेंगे? दो ट्राइंगल पहले लेंगे. कौन कौन से दो ट्राइंगल कॉन्ग्रुएंट प्रूव करेंगे? इन ट्राइंगल कौन से ट्राइंगल लेंगे? ADE एंड ट्राइंगल BCF. क्लियर? पहले क्या लेंगे? एंगल 1 इज इक्वल टू एंगल 2. इसको हम 1 नाम देंगे, इसको हम 2 देंगे. क्यों? रीजन लेंगे करस्पॉन्डिंग एंगल. करस्पॉन्डिंग एंगल्स फॉर्म बाय व्हाट? फॉर्म बाय AD पैरेलल टू BC विथ ट्रांसवर्सल AB. AF with transversal AF. Clear? It's a corresponding angle formed by AB parallel to CD, AD parallel to BC with transversal AF. 1 and 2 आया. इसको हम नाम देंगे 3 and 4. तो एंगल लिखने का short form. It is a short way of writing this. Second condition is angle 3 is 4. That is also pair of corresponding angle. Angle formed by which two line? ED parallel to FC with transversal AF. ट्रांसवर्सल वो ही रहेगा, ट्रांसवर्सल AF. ओके, दो एंगल हो गए. एंड थर्ड इज AD इज इक्वल टू BC. क्यों? ऑपोजिट साइड ऑफ पैरेललोग्राम. ABCD is a parallelogram, so opposite sides are equal. Therefore, triangle ADE is congruent to triangle BCF. Why? By SAS rule. SS नहीं, AAS rule. Okay, by AAS rule. Okay, therefore we have learned when triangles are congruent, then area of triangle ADE is equal to area of triangle BCF, We know congruent triangles have equal area. Now adding that portion on both sides. Area of triangle ADE plus area of portion EDCB is equal to area of triangle BCF plus area of portion, close figure, EDCB. EDCB. क्लियर? तो ये बन जाएगा, ये दोनों को ऐड करेंगे तो बन जाएगा एरिया ऑफ पैरेललोग्राम ABCD, एंड ये बन जाएगा एरिया ऑफ पैरेललोग्राम EFCD. ओके, so two parallelogram on the same base and between same parallel are always equal in area. Clear? Therefore I can say that parallelogram on same base, parallelograms on the same base and between same parallel are equal in area. Clear? Now the converse of this theorem we are accepting without proof. The converse of this theorem, of the above theorem, is also true, but we are accepting it without proof. What is the statement of the converse of this theorem? Parallelograms on the same base, same or equal base, same or equal base, and having equal area, and having equal area. दो पैरेललोग्राम का बेस सेम है या तो इक्वल है, and their areas are also equal. Then they lie between the same parallel, lie between the same parallel. Parallelogram on the same base or equal base and having equal area lie between the same parallels. That is the converse of this theorem. Argument से प्रूव कर सकते हैं क्योंकि हमको पता है what is area of parallelogram. Tell me. It's a base into height. Okay. So suppose two parallelogram with base same and area is also same. That implies their height is also same, and height is only same. This is only possible. This is only possible if they lie between same parallel. Okay, if they lie between same parallels. Okay, clear? So converse of this theorem we are accepting without proof, only I have explained orally. Now theorem number 9.2. It is based on two triangles on the same base and between the same parallel. They are always equal in area. Theorem says two triangles. I can use it for proving any rider. Okay. Two triangles on the same base or equal base and between same parallel. Same parallels are equal in area. Because इसका भी without proof we are accepting, but argument से हम बता सकते हैं. We know that. What do you know about area of triangle? We know that area of triangle is 1/2 base into corresponding altitude. Okay, जो base है उसका corresponding altitude. So therefore two triangles with equal base and equal heights, because altitude are also equal, they are between same parallel, so they are having equal heights. Okay, are equal in area, are equal in area but natural by definition. This theorem we can verify by using this formula of area of triangle, 1/2 base into corresponding altitude, that is corresponding height. So when the triangle are having same base, so base is same and they are between same parallel, matlab their corresponding altitudes are equal in height. Okay, so base is same, height is same, so area must be equal. Now theorem 9.3. It is nothing but the converse of 9.2. It says two triangles with same base, two triangles having the same or equal base and equal area, base equal and equal areas, lie between the same parallels. Okay, now that complete your theory of chapter number 9. Okay, now one more thing I have discussed with you, कि if the triangle and parallelogram are on the same base and between same parallel, then what is the relation between area of triangle and area of parallelogram? Area of parallelogram is 2 times area of triangle, or area of triangle is half time the area of a parallelogram. Okay, so all these 4 theorems you have to remember, because these riders, where we are given something and we are asked to prove something, so that proof is depending on any of these 4 theorems. Okay, we can use this. Not only that, we are going to use some rules of congruency of triangle while doing sums from 9.1 and 9.2. So you have to remember these 4 theorems about relation, and also you have to remember those 4 congruence rule of triangle.